A viewer has asked how to deal with inequalities on the graphical calculator. Now, it can't deal with them strictly algebraically, but what it can do is represent them graphically, which can be very, very helpful depending on what we're trying to achieve. So imagining that we had something like y is greater than x plus 3. That's a very simple inequality that we wanted to represent. If we notice up here, it says y equals. We can change this to be y is greater than. So if we press type, we get our usual things, y equals, polar, parametric, and so on. Pressing to the right, we get our inequalities. So we can choose y is greater than. You can see it's changed up here. Now all we need to do is type in x plus 3, press enter, and it will draw the graph, shading in the part where y is greater than x plus 3. And of course, what we can do is we can represent any type of expression that we want, x squared plus 3x, or whatever it might be, draw it, and it will still be able to work out where y is greater than that graph. Of course, you may have some other problem where you want to evaluate something like where is x squared greater than x plus 1. Now there's two ways of doing something like that. What I would do, go into the graph, change it back to y equals, and you can then draw, if we delete that one, you can then draw x squared as one graph and x plus 1 as another one. Drawing that graph, of course, there's the two parts. And what we're looking for is when is x squared greater than x plus 1? Well, of course, we're looking for when is this curve greater than the straight line. And of course, here it is greater, and here it is greater than that one as well. In this middle section, we don't want that. So, of course, we want all of the x values to the right of here and all the x values to the left of there. And what we can do is if we press G solve and find the intersection of those two lines, we'll have a think for a moment. There it is, it's found that intersection point. Now this is going to be some peculiar root value, and pressing right will find the other one. So we can check it numerically. It won't give us the fractional root sort of answer, but we can still find the numerical answer and then check from our working. Of course, you would find them by turning that into a quadratic and solving it. The other way of solving this would be to say, well, we could rearrange this to give us x squared minus x minus 1 is greater than 0. And then, of course, if we go in and plot that one, let's delete those, and go x squared minus x minus 1. So we've just got one graph appearing. When is that greater than 0? Well, of course, for this section here and this section here. We don't want that bottom bit. So again, we could find those two roots and say it's everything to the right of there, or to the left of there. So it can't quite do algebraic inequalities, but we can certainly work with inequalities in the same way.